All right, this is this week's grade 8 lesson on 6.3, solving equations involving fractions. So we did solving equations about 6 weeks ago. It was 6.1, 6.2. You might want to go back there for a little bit of a review, or if this is years in the future, maybe it's a different case. Here we are. So first we're going to do a bit of a review. How can we balance a fraction? We need to get the opposite to isolate something. And what I mean is this. Let's go simple. N plus 6 equals 3. What we learned last time was that the first thing we need to do is get this on its own. And I used to always say, if we want to get him, we got to get his friends away from him. It's easier to jump the variable without someone else around. So we're going to do the opposite. We're going to go negative 6 on this side and negative 6 on that side. The reason we go negative 6 on both sides, because we need it to be even. If it's not even, it is no longer equal. So I now have n, because this is canceled, and 3 minus, 6. 3 minus 6, of course, is negative 3. Now let's see if I have the right number. The first thing we need to do, we need to plug it back in and see if we are correct. Let's plug it back in. N plus 6 equals 3. So let's plug it in. If we think n is negative 3, we will replace it and see if it is true. Sure enough, we get to 3 is equal to 3. So therefore, n is equal to minus 3. So now that we've had our brief review, we're going to get into the examples from the assignment. Which number could you multiply 3 over 7 by to get the product of 3? So which number could you multiply 3 over 7 by to get 3? All I did is I took this sentence and I rewrote it one piece at a time. Which number could you multiply 3/7 to equal 3? First, I got a little confused. I looked at this and I thought, well, we've got times 3/7, but we need to divide it by 3/7. And I got a little confused. But then it occurred to me, n is the same as n over 1, is it not? I believe it is. N is the same as n over 1. So really, I've got n times 3, got 3n, 1 times 7 over 7 equals 3. This is what number multiplied by 3 divided by 7 equals 3. Now to explain that, instead of n, I put n over 1 times 3 over 7. n times 3 and 1 times 7. n times 3 and 1 times 7. So now I've got to get this on its own. I have divided by 7, so I'm going to multiply by 7 on both sides. These cancel out. I now have 3n equals 21. Now I've got multiplying n by 3, but I still have to get n on its own. So I'm going to divide by 3. That cancels out, and it looks like n is equal to 7. Now that I think I know what the number is, I need to plug it back in and see if I'm right. Now let's see if it's within the screen. If I go beside, we're just going to shift over slightly. So we're going to plug this back in. I'm going to rewrite it. I should write it as 3n. A number multiplied by 3 divided by 7. So if I think n is 7, let's rewrite it as 7. 3 times 7 is 21 over 7, which equals 3 over 3. I must be correct that n equals 7. Otherwise, it would not have balanced. Now this is where you're going, okay, I get it. No, wait, I don't quite get it. And I don't think you do yet, because I know I got a little confused just reviewing this. So let's take a look at another example. The next example in your assignment says, which number could you multiply 5 over 6 by to get the product 5? So I'm going to write that one piece at a time. Which number could you multiply 5 by 6 to get 5. Well, first, this is like n over 1. So that's like 5n over 6. n times 5, 1 times 6. So I have a number multiplied by 5 over 6 equals 5. That's where we are. So I'm going to multiply this first. Because right now it's all being divided by 6, I need to multiply by 6 on both sides so that it cancels out. There we are. Now I have 5 times n. The ultimate of 5 times is divided by 5. Do it on both sides so it balances. That cancels out. And we have 6. So I think n is equal to 6. But of course now I need to plug that back in and see. So let's shift our camera over again. Oh dear. I see that the camera wasn't quite on there for part of my thing. Here I should reiterate. We had n times 5, 6. A number times 5 over 6 equals 5. But we once again remembered that that is like 5n over 6. n times 5 is 5n. 1 times 6 is 6. We did times 6 to cancel out, and we got to 6. So let's plug it in. So if I have 5n equals 5, let's replace that with 5 times 6. So I now have 30 over 6 equals 5. Sure enough, I get to 5 equals 5. Since this is balanced, I must be correct that n is indeed equal to 6. Now let's see if there's any other examples that we need to go over. Let's go back to our screen. It says Grandpa has enough gift certificates to give the same number of gift certificates to each of his 4 grandchildren. After Grandpa gives them certificates, each grandchild has 5 gift certificates. How many gift certificates does Grandpa have? Write an equation, solve the equation, verify the solution. So first I'm going to draw a picture of what this is. Here we've got old Grandpa. There's his beard, because he's an old Grandpa. And he's got all these gift certificates to give out to all his grandchildren. And he has 4 grandchildren. And here's his little grandchildren all running around. And it says he gives each of them 5 gift certificates. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It says how many gift certificates did Grandpa have in the first place? Well, as you can clearly see from the picture now, he had 5, 10, 15, 20 gift certificates. Well, now we need to write this as an equation. What we didn't know was how many gift certificates he had. So we're going to say that the gift certificates are equal to G. That's going to be my letter. G is going to represent the number of gift certificates we didn't know beforehand. So we know that the gift certificates divided into 4 equals, hold on. There we go. We know that he's got some gift certificates, and that when he divides them into 4, that equals 5 per kid. So we just got to find out what he's got here. Well, now we're going to solve it. So G is divided by 4. We need to get G on its own. What's the opposite of divided by 4? Times 4. So we're going to go times 4, times 4. Cancels out. So G is equal to 20. That seems to be what we have. But it said we should verify the solution. To verify a solution, that means we've got to plug it back in. So let's plug that back in. We had G divided by 4 equals 5. We think it's 20. So we're going to replace that G with 20 and see if we get the right number. Sure enough, we got 5 is equal to 5. Since that balances out, we must be correct that G is equal to 20. I think that is our last one that we have, and if you need a little more about that, I'll just turn you back to the screen and you can see that that example is actually being used right in your textbook there, so you can take a second look at it, so you can read it there, or you can see it here in the video portion as well. If you have any more questions, as always, you know that I'm available during my breaks. I love questions. The only stupid question is the one not asked, so don't be afraid to ask it, and I look forward to talking math with you. I hope these videos help.